glad you guys appreciated that. So I'm going to ask you a question. I want you to raise your hands. How many of you have ever taken a rock and smashed it open to see what comes out? Yeah, several of you. People have been smashing things together to study what comes out of them for as long as we've had hands to smash things with. Today, I'm going to tell you about a field of science that's gotten really, really good at smashing things together. Elementary particle physics studies the smallest constituents of our universe to try and answer some of the biggest questions. Questions like, what is dark matter? Currently, gravitational observations made by astronomers tell us that there is more matter in the universe than what we can see. We call this unseen matter dark matter. One of the goals of elementary particle physics is to try and look for new particles which might give us clues about dark matter. This is the LHC, or Large Hadron Collider, and it is the largest and most powerful particle accelerator in the world, located in Geneva, Switzerland. This is me at the LHC last summer, a fun opportunity you might also get to have if you come to Rice. As you can see from all of the presentations, there's a lot of travel opportunities. The LHC uses detectors like this one to study the particles that are produced in proton collisions. Most of these particles are described by what we call the Standard Model of Physics, which summarizes most of our current understanding of particle physics. However, since the Standard Model is unable to explain things like dark matter, we have good reason to believe there are more particles to be discovered. But we haven't found them yet, so we know they must be rare and difficult to find. Imagine you were smashing rocks together, looking for a diamond. You'd probably have to smash a lot of rocks before you found the diamond. This is what the LHC does. At peak performance, it collides close to 1 billion protons every second. This gives us a lot of data to study. Too much data, in fact, to study all of it. One important aspect of physics at the LHC is choosing the right data to save and study later. This is where my research comes in. What if, instead of going through all of this data ourselves, we could teach a computer to do it for us? In my research, I look at ways to use machine learning to select interesting physics events from particle physics data. As the name implies, machine learning is a way of teaching a computer to learn, much the same way that you learn. We start with an untrained model. We give this model training data. Think of this as being your teacher giving you practice questions. For the training data, we know the right answers, so we can correct the machine when it makes a mistake. The more the machine practices, the better it gets. Once the machine has done a lot of practice and is very accurate, we graduate the machine and use it to study real data produced at the LHC. For the past year, I've been studying classes of machine learning which haven't yet been tested at the LHC to see if I can find one which improves the way in which physicists select which particle physics events to save and study later. If we use new machine learning methods to save better physics events, then we're more likely to find new particles which might give us clues about things like dark matter. In other words, if we improve the way in which we sort through all the rocks we've smashed, we're more likely to find the next diamond in the rough of particle physics. Thank you.